Alright, so today basically what we're going to do is start or actually continue working on section 9.3, which covers more items and topics on logarithmic relations, functions, being able to put them together, expressions and things of that nature. So my client here will just kind of be interacting for a little while, and you know, just take the session as normal. So hopefully you guys will learn something, you know, maybe listen in, things of that nature. So we'll begin exactly where we left off at on the last particular session. So far, how has everything been for you so far?
It's been really easy.
Pretty easy?
Mm-hmm.
Okay, good. That's a good look. Everything, all the notes and stuff like that, they were to look at, and it's been pretty reasonable for you?
Yeah.
Things like that? Okay. Good. Well, logarithms and exponentials are not too hard, not too bad, so we should have fun with these. Okay. Now, properties of logs, it's something that's kind of it's pretty simple if you think about other rules, right?
Mm-hmm.
So, for instance here, I'm going to get you a piece of paper or two. Does that pen still work for you? Alright. Alright, so basically, product property or logarithms, what that states to us is of course, this is part of Algebra 2. Those of you out there need to know what topic this is. It's actually Algebra 2 section. The product property of logarithms is the sum of the logarithms and its factors. So the sum of factors in the logarithm. Okay? Sum of the logarithms and the factors. So for all positive numbers, m, n, and b, let's look at this. For positive numbers, n, m, and b, right, where b does not equal 1, we have this. Log base b of m, n, okay, equals this. Log base b of m plus log base b of n. So when you multiply, basically, when you remember in exponentials, when you multiply, you add the exponents, right? The exponents. Okay, so when you divide, you subtract the exponents. Outstanding. So here, when we have multiply, we actually do the same thing scenario in the logarithm. So log base b of m plus log base b of n gives us our property here for the product. Now, an example of this would be something like log base 3 of 4 times 7, which is going to be log base 3 of 4, right? Mm-hmm. Plus log base 3 of 7. And we would calculate that on our calculator because we don't know off the top of our heads what this is, obviously, unless you're like, you know, a human calculator, right? Mm-hmm. So that's what that would be. Any questions so far?
No.
Okay. Now, as far as the next part goes, it says use log base 5 of 2, right? Approximately 0.4307 to approximate the value of log base 5 of 250. So log base 5 of 250 and log base 2 of or log base 5 of 2. That log base 5 of 2 is approximately 0.4307. So the first thing we want to do is kind of break 250 down, right? Would you agree with that?
Yeah.
So in this case, we have log base 5 of 2 is going to give us log base 5 of 2 and then times, or I'm sorry, log base 5 of 2 times 5 cubed. Either way will work. Right? This is what this breaks down into. Does that make sense? Mm-hmm. So log base 250 breaks down to log base 5 of 2 times 5 cubed. Okay? Now, this is going to equal, based on our multiplication or product property, this is going to then equal log base 5 of 2 plus log base 5 of 5 cubed. And what's 5 cubed?
5 cubed, 25.
125,
Oh,
right?
125.
125, right?
Yeah.
Okay, so here, the property of logarithms that we have, actually in this case here, whenever we have a base and the number here is the same, we can technically cancel this out. Okay, so this actually becomes 3 plus log base 5 of 2, right? And if you see here, we already have log base 5 of 2, don't we? Mm-hmm. So log base 5 of 2 is approximately, what, 0.4307? So this then turns into 3 plus 0.4307. And our answer is going to be 3.4307. Did that make sense? Any questions on this part or this part here so far?
No.
It's just converting basically the logs, right? It's just converting them to different properties. So not too bad of a time there. Let's go to the next portion. Okay, so if we look here and see log base 2 of 3 is approximately 1.5850. How do you think we should break that particular problem down? What do you think is the best thing to do? And I'm actually going to erase this part here so it's clear for us. So I'll kind of leave that over here. You can kind of see the example we did before. So log base 2 of 3, I'll use a different color. Log base 2 of 3, okay, is approximately 1.5850. Now, I want to find out log base 2 of 96. So what are we going to use? How are we going to break this up? First of all, I know we're going to do log base 2 of something. Would you agree?
Yeah.
So what's 96 maybe divided by 3? You have a, oh yeah, you have the calculator right there.
32.
32? So even if we had 3, so 3 times 32 maybe?
Mm-hmm.
Something like that?
Yeah.
Okay, cool. Now, 32 is basically, isn't it maybe 2 to the 5th? Try it on the calculator. Tell me if it's 2 to the 5th real quick. Let me know what you think.
Yeah, it is.
It is. Okay, cool. So 2 to the 5th equals 32. Equals 32. And I can then take 2 to the 5th and replace it down here. What do you think about that? Does that make sense? Would you agree with this part that 2 to the 5th equals 32 shifted down here to our position? Mm-hmm. Like before, right here, right? Yeah. 5 cubed. So here, I'll break this up into log base 2. Oops, let me erase this part now. Log base 2 of 3, right, times log base 2 of 32. Based on our product rule, it tells us that we need to add the 2 together. So I'm going to switch this to 2 to the 5th. Log base 2 of 3 times log base 2 of 2 to the 5th. And now, what did I say earlier? When you have a base that's the same as the number here, you can do what?
Cancel it.
Cancel it out. Outstanding. So now I take this, cancel that out, and I'm left with log base 3 or log base 2 of 3 times, that's it, right? Or it's left over 5, I'm sorry, plus 5. Okay, when I multiply, I add the 2 together. Okay? Because then it would be, in essence, it would be the 5 times the log 3. Okay? Mm-hmm. And then log base 2 of 3 is 1.58. So 1.5850 plus 5 gives me 6.5850. In this case, it should be answer choice what?
It should be D.
D is in dog. Look at that. Perfect. Right? Perfect. No flaws in this particular problem. It's a good look for us. Makes sense. So what we did again, we took the product property of logs. When we multiply, we add. The sum of the factors we took. In this particular problem here, we took log base 2 of 3 is approximately 1.5850. Our problem was to figure out log base 2 of 96. That was good for us. And then we broke it apart to 3 times 32 as you stated, right? 2 to the 5th is 32. So we broke it apart here, crossed our base out and the number. We got 5 plus log base 2 of 3, and it equals this. Now there's something that you don't know, or something that all y'all out there don't know, that or don't remember maybe, is that the log of 2 base or log base 2 of 3, technically when you take the you can't just figure this out in your head. But on the you can't just put it in the calculator like that either, can you? So we use what we call a change of base formula. We'll learn about that maybe a little bit later, but change of base formula is log base, I'm sorry, not base, log of 3 divided by log of 2. You always take the log of the outside number first, then do the log of the inside number second. Okay, that's how you do the change of base. Does that make sense? All right, cool. Sounds good there. Do one more example. I think that might be enough for the video here. Okay, so remember we talked about the quotient property. I said if you divide, you what?
You subtract.
Subtract, right? Can I erase all this real quick?
Oh yeah.
Okay. So erase this, and we'll go over the division property real fast. As you see, I finally got my eraser.
Yeah.
Alright, so quotient property of logs. Alright, so now the logarithm of a quotient is the difference of the logarithms of the numerator and the denominator, right? So we have log base b of mn. That's my little timer there. Let me know it's close to my end time for the first video here. Log base b of m over n. If I have any numbers, right? Could be 5, could be 6, 10, 100 million, right? What I'm going to do is take this number, log base, whatever number it is, subtract it of the n. Log base b of m minus log base b of n, like that. Because I subtracted here, okay? Key thing, key point, like I said, to remember is when you divide, you subtract. You subtract. Okay? Now, let's look at an example of that. And again, b does not equal 1. Okay? So it says use a log base 6 of 8 equals 1.1606 and log base 6 of 32 is approximately 1.9343 to approximate the value of log base 6 of 4. Well, what we'll do is on the next note on the video, we'll continue on that particular problem.